The moon has always been a faithful companion to Earth. For billions of years, it has orbited around our planet. But here is a surprising fact you might not know. The moon is slowly drifting away from Earth. Each year, it moves about 3.8 centimeters farther. That's roughly the same speed your fingernails grow. It doesn't sound like much, right? But over millions of years, this tiny drift makes a huge difference. Scientists discovered this by bouncing lasers off mirrors on the moon. These mirrors were placed there during the Apollo missions. By measuring the time it takes light to return, they can track the moon's exact distance with precision. The results are clear. The moon is escaping, little by little. But why is this happening? The reason lies in tides. Earth's oceans are pulled by the moon's gravity. This creates tidal bulges that move slightly ahead of the moon. These bulges push on the moon, giving it extra energy. That extra energy makes the moon spiral outward. Meanwhile, Earth loses a bit of its rotation speed. That means our days are slowly getting longer. A day was only 18 hours long 1.4 billion years ago. Today it is 24 hours. And in the far future, days may stretch to 30 hours. Imagine having to work for 20 hours a day. Jokes aside, this change affects life on Earth. Tides control coastal ecosystems. They also regulate ocean circulation. If the moon drifts farther, tides will weaken. That could impact marine animals like crabs, fish, and sea turtles. Many of them depend on tides for reproduction. Without strong tides, entire ecosystems may collapse. Humans would feel the effects too. Coastal communities could change dramatically. Fishing patterns might shift. Even climate could be influenced. Another important role of the moon is stability. The moon's gravity keeps Earth's axis tilted at 23.5 degrees. Without the moon, Earth might wobble chaotically. Seasons could become unpredictable. Winters might be extremely cold one year, and strangely warm the next. Agriculture would face massive challenges. Life as we know it might not survive. So, will the moon ever completely leave Earth? Not anytime soon. At the current rate, it would take billions of years. By then, the sun will have expanded into a red giant. Earth itself may no longer be habitable. But thinking about this drift makes us reflect. Our planet and its moon are in a constant dance. It is a cosmic relationship that is always changing. We are witnessing a very slow, but very real process. So slow that no human will ever notice it directly, yet so powerful that it shapes Earth's destiny. This discovery also teaches us humility. We tend to think of the Earth-Moon system as stable, but stability is only temporary in the universe. Change is the only constant. Let's think about the numbers again. 3.8 centimeters per year. In 100 years, that's about 3.8 meters. In 1,000 years, 38 meters. In 1 million years, 38 kilometers. That's already significant. Over 100 million years, 3,800 kilometers. That is enough to change tides dramatically. But there is more. As days get longer, Earth's rotation will continue to slow down. Energy balance between Earth and Moon shifts. This process is called tidal acceleration. It is one of the most fascinating interactions in planetary science. Some scientists even call it a gravitational handshake. A handshake that slowly pushes the moon away. Interestingly, without this process, the moon might have already fallen back to Earth. Instead, we get the opposite. It is drifting away. So, what will happen to humans in the near future? Don't worry, for the next millions of years, tides and days will remain familiar. No dramatic change will happen in your lifetime. But this drift reminds us that our planet is not eternal. It is part of a larger cosmic system. Even small changes have giant consequences. Let's consider life 1 billion years from now. By then, Earth's day could be around 30 hours. Imagine how humans would adapt. Work schedules, sleep cycles, society all would shift. Animals would adapt too. Plants would grow under longer daylight hours. Night-active animals would face darker skies. Stars would shine brighter without the moon's glow. Nights might feel more mysterious. The cultural role of the moon would also change. Poets, artists, and dreamers might see it differently. Humanity's connection to the moon runs deep. From myths to calendars, from love songs to scientific exploration, the moon is more than a rock in space. It is a mirror of our humanity. And yet, it is slipping away. Slowly but surely. Let's not forget how we discovered this. Apollo astronauts placed retroreflectors on the moon. Scientists still use them today. Lasers shot from Earth bounce back from the moon's surface. This simple experiment proves the moon's drift. It is one of the greatest legacies of space exploration. Proof that science can measure even the smallest motions. And those motions reveal the grand story of Earth. The moon is not static. The Earth is not static. Both are evolving together. Scientists also ask another question. How did this drift begin? Billions of years ago, the moon was much closer. Some say it formed after a giant impact. A Mars-sized body collided with Earth. Debris from that impact formed the moon. At first, it was only 22,000 kilometers away. Now, it is 384,000 kilometers away. That's an incredible journey. And it continues. Slowly, but steadily. The moon has always influenced life on Earth. From early single-celled organisms, to dinosaurs, to humans watching it today. Without the moon, life might not have evolved the same way. It stabilized Earth's tilt. It created tidal pools where life may have begun. It guided early humans to track time. And it inspires us even now. So the drift is not just a number. It is a reminder of how fragile our balance is. A reminder that nothing lasts forever. But also a reminder that change brings new possibilities. One day, humanity might live on the moon. Or even beyond. By then, its distance may matter in a different way. Imagine future generations looking back at Earth. They would see a smaller, distant blue planet. Just as we see a smaller, distant moon, our perspective would flip. The drift tells us something profound. We are part of a moving universe. Nothing stands still. Every orbit changes. Every rotation slows down. Every tide shifts. And every life adapts. Science helps us understand this journey. It shows us connections we cannot see with our eyes. It opens a window into deep time. Beyond human history. Beyond civilizations. Beyond humanity itself. The moon's drift is a slow story. But it is also a powerful one. A story of gravity and motion. A story of cause and effect. A story of cosmic relationships. The moon may seem silent, but it speaks through science. It tells us I am moving. It tells us Earth is changing. It tells us nothing is permanent. The more we learn, the more we realize our universe is alive with motion. From galaxies colliding, to stars being born, to moons drifting away, we are part of it. We are witnesses, and we are storytellers. So the next time you look at the moon, remember this: it is not fixed in the sky. It is on a journey away from us, centimeter by centimeter, year by year, generation by generation, until billions of years from now, when Earth and moon are no longer as we know them. The drift will continue, and the story will go on. Strange, isn't it? That something so small can mean so much. But that is the essence of science, finding meaning in the tiniest changes, and realizing they shape the biggest futures. The moon is drifting away. It always has. It always will. Weird, but real, and absolutely fascinating.